Welcome to our second lecture on the central nervous system. Today's lecture, we'll be focusing on the spinal cord. So, why is the spine the central nervous system? We'll answer that question in a second. So, our learning objectives are to describe the spinal cord and to identify features of the spinal cord. So, what does the spinal cord do? What is it doing? Well, we have the spinal cord, and it is a relay between the brain and the rest of the nervous system. So it's a relay from CNS to PNS. But the central nervous system integrates, and the spinal cord is in the central nervous system. So what does it do? Well, it has to integrate, and it integrates messages and reflexes. Integrates messages and reflexes. So, the spinal cord is going to integrate messages coming to and from the brain. You can actually have the spinal cord do things on its own as well. It integrates limb patterns such as walking, playing the piano, hitting a baseball, and it also integrates reflexes. So this guy, he stepped on a tack. Oh no. Yes, that's my favorite example. And the message goes up the sciatic nerve. It's going along this unipolar neuron. See the cell body? And it goes to these nuclei in the dorsal or posterior horn. Now, all of this in here, all of that is integration neurons. So what's going to happen is they're going to integrate, and it's going to send a message to the quadriceps saying, relax, we're stepping on a tack. We don't want to step harder. It sends a message to the hamstring saying, contract, pull away, we're hurting ourselves. At the same time, messages are going to cross this commissary tract. It is going to send messages to this hamstring saying, relax, and this quadriceps saying to extend. It's called the cross extensor reflex. So it's integrating all of this action. So the spinal cord is a link between the brain and the peripheral nervous system. It has afferent tracts. Remember, those are sensory tracts. So you touch something hot, you're going to do a withdrawal reflex, but messages are going to come in. They're going to on these unipolar neurons, and they're going to junction to these afferent tracts, which are sensory tracts. Now, touching something hot is going to actually be a withdrawal reflex in the spine, but also has motor tracts coming down. So we have motor tracts coming down. So these are, what are they called? It starts with an E. E. They're called efferent tracts, and their signals are going to leave this anterior horn, and they are going to go out. So it has ascending afferent tracts, descending efferent tracts, and it integrates reflexes. So if this was actually the withdrawal reflex, it's going to be integrated here. The motor signals leave that horn and go out this anterior route to a muscle. So efferent. So I'll send the signals to muscles. So the spinal cord is located in the vertebral canal. So here it is in the vertebral canal. And it starts at the foramen magnum. It blends in with the medulla oblongata. And you have nerves exiting at regular intervals. So you have one nerve exiting there, another one there, all the way down to the bottom of the spine. And they're exiting through the intervertebral foramen. So we have two vertebrae here. We have the disc right here. And the nerves are going to exit between the two vertebrae. So that's the intervertebral foramen. Now it ends at L1 or L2. So here is the spinal cord. It ends between L1 and L2. So this structure right here, so that structure right there is called the conus medullaris. There's two L's right there. And we have nerves going out at regular intervals. Now the problem is the spinal nerves go all the way down to CO1. That's L2. So you actually have these nerves that are extending from the conus medullaris that are also still leaving. And these nerves sort of look like a horse's tail. So they are called the cauda equina. So cauda equina, tail of the horse. Now there's 31 pairs in total. So this would be the first one, it's actually called cervical one, all the way down to the last one, which is coxal one. So again, here's the spinal cord. It ends right here, which is the conus medullaris. Oops, there's conus medullaris. And this remaining part right here is the cauda equina. So see, the spinal nerves continue to exit all the way through the sacrum. So if I were to do a cross section of the spine, it's actually oval. It is dorsally ventrally flattened, or anterior posteriorly flattened. It ends at L2, right there, which is the conus medullaris. And you actually have thickenings in the cervical and the lumbar region. So if I were to redraw it here, it's thicker here in the cervical region. It thins out in the thoracic region. Gets thicker again in the lumbar region. And then what does it end in? The conus medullaris. So here's the cervical enlargement. Here's the lumbar enlargement right here. So question for you. What would you call this region of the spine right here if this is cervical and this is lumbar? I really hope you said thoracic. Next question. What about all the nerves going down past L2? Remember all these nerves? What were those called? The cauda equina. So they're called the cauda equina. So, in case you haven't figured out, I have an obsession with the end of the spine. It ends at L2 with the cauda, or conus medullaris. And you have spinal roots that are dangling down. So spinal roots are dangling down. And it looks like a horse's tail. I've had several equestrian students who say, yes, it actually looks like the horse's tail when we pull it out. And so that is the cauda equina. Now, there's an extension of the pia mater that runs right down the center. That is the filum terminale. And this actually braces the cauda equina all together. So if we were to look at this picture of the real spine, here's the conus medullaris right here. There's the cauda equina, and the filum terminale is this thin film in the center. The spinal cord has several regions. It has a cervical, which is right here, named for the cervical vertebrae. It has a thoracic, right here, named for the thoracic region. The sacral and lumbar are actually right here at the conus medullaris. And then the very tip of the conus medullaris is the coccygeal. And they're named for not actually where they are, but where their spinal nerves exit. Now, in this region of the cervical and thoracic, it's literally right there. But down here, it's all lumped together. Now, you have thickenings at the cervical and lumbar regions. Those are called the cervical and lumbar enlargements. Remember my beautiful drawing over here? We also have that because you have motor neuron cell bodies. Why do you think you have motor neuron cell bodies in those regions? Oh, you have the limbs here and down here. So you have more cell bodies for the limbs. Now there's 31 pairs. Wait a second, that math doesn't quite work because there's only 30 vertebrae there. Oh. Uh-oh, how the heck? There's 8 cervical? That's weird. But there's 12 thoracic vertebrae, 12 thoracic nerves. 5 lumbar nerves, 5 lumbar vertebrae. 5 sacral, 5 sacral vertebrae and nerves. And you only have one at coccyx 1. So yes, there really are 8 cervical nerves, but 7 cervical vertebrae. Let's look why. So here's the spinal cord. It looks like this person might have some mild scoliosis. Yes, I flunked straight lines. And C1 is going to exit, so nerve C1, above the cervical vertebrae here. So nerve C1 exits above the atlas. C2, that exits above the axis. So this would be C3 and so forth. So where the heck do we get that 8th vertebrae? Well, for some reason, C8 is actually exiting below. So C1 through 7 exit above, and then C8 exits below C7. So that's how we end up with 8. You start numbering for C1 through C7, it exits above the cervical vertebrae with that name. Then C8 exits below the 7th cervical vertebrae. Yes, it is confusing. So again, C1 through 7 exit above the vertebrae they're named for, and then for some reason we have our glitter bomb C8 that exits below. Thoracic are much better behaved. We have T1 exiting below the first thoracic, T2 exiting below the second, and what do you think about T12? Yep, below the 12th thoracic vertebrae. So what do you think? Where do you think L1 exits? Correct, underneath the lumbar vertebrae. So L1 nerve exits under L1 vertebrae. L2, below this vertebrae. L5, you named it, it exits below the 5th vertebrae. And so forth. So the rest of the vertebrae, rest of the nerves, all exit below the vertebrae they are named for. Okay, let's do some assessment here. The cervical and lumbar enlargements, because they're the beginning and end of the swelling because of cell bodies for muscles, swelling because of greater gray matter, or both 2 and 3. So let's think about it. Cervical, that would be going to the arms. Lumbar must be going to the legs. So that one is correct. Well, where are cell bodies found? Oh yeah, cell bodies are actually found in gray matter. So the cell bodies for these are actually found in the anterior gray matter. So it's actually 4. Both of these are correct. But we're going to talk about this in a minute. So what do you find at the end of the spine, which is at L2? Conus medullaris, cauda equina, or nasus porcus. So medullary cone, horse's tail, or pig's nose. This is what is at L2. This are the nerves that are dangling down in the vertebral foramen. And that's a pig's nose. True or false? Nerves dangle down below the end of the spine and exit in the lumbar and sacral regions. True. And that's the cauda equina.